Hello guys, and welcome back for week 5's lesson. So today we are going to learn about on how to install your Arduino IDE, as well as how to set up your IDE, and of course how to read and write codes and understand how it works. So let's go. So first off, in order for you to be able to use your Arduino or program your Arduino, you need to download its IDE, where IDE stands for Integrated Development Environment. Okay, so if you type Arduino IDE on your browser, it will the first on the list is actually the Arduino's software or IDE. Okay, so when you're on their homepage, just scroll down and you will see this area where you can download the app. So if you're using Windows, again, sorry, this one is for laptops and PC or desktop users only. Okay, so it's not applicable to mobile, but I think there are mobile applications, but for now let's stay in this. So if you're using Windows operating system, then you can choose from this one. So the first one is the one where you need to install, while the second one you just download and open the file. So if you don't want to install the application, then choose the second one. Next one is for Mac OS users. There you go. And another type of operating system is your Linux. So click one, for example this one. So I downloaded this one a while ago. Okay, and then you install and open your file. So when you open your file or the application, you are presented with this window. Okay, so this window now has some parts that you need to understand. Okay, so first off, we have your menu bar. So I will be adding a link in this post with this video for you to be able to see the detailed description of each of this menu. Okay, so for you to know how to use it. There you go. Tools. So this is your menu bar. Next line is your tools. This one is where you will be mostly, or these are the tools that you will mostly be using. Second one is your text editor or your code editor. This is where you type your code. Okay, and the third one is where it will be displaying errors, the status of your of your code. Okay, so let's go to your toolbar. So first one, we have your verify. So if you're done with your code and you want to check if there are errors, you can click verify to check. And if there are no errors, then okay, you just click and wait for it to finish. And once it's done, okay, there's no error, so it says done compiling. Okay, then you're good to go. But let's say, for example, let's remove this one and verify. When we save here, so you need to save actually, you will see that it detects an error. Okay, so it turns orange. Okay, so it says here expected initializer before closing token. So it's expecting an opening because we removed the other one here. Okay, so when we put that back, we check for errors, and now it's good to go. Next one is your upload. So when you click this one, it will transfer this code on your PC, and send it to your Arduino MCU. Remember your MCU? Yep, that's right, this one. Okay, this is your MCU. So if you connect it using your USB cord, then it will be sending the data or the program to your board MCU. Next up, but I won't be clicking that for now. Okay, next one is new. So if you want to create a new code, new sets of code, then you can just click this one. So it will present you with a new window. All you have to do is type your code. Next one is if you want to open a previously saved code, okay, or if you want to try and test out some other codes that are that comes with your Arduino. So these are already or programs that are ready for you to use. For example, this one. There you go. So you can use this pre-made codes for your robots as well. Next one is we have save. So if you have done some coding, okay, for example here we say pin mode, okay, LED is an output module, etc. And then if you want to save, just save it. And even if you close it and you want to open it again, you can see it there. Okay, now going back to your menu file, the thing that you need to remember here is found in your tools, board and port. Okay, so before you can upload, or before you upload your program, you need to set both of these ones first, because if you don't set them up, your computer will not be able to identify first the board, what type of board you're using. Okay, because in case you don't know, Arduino is just one type of MCU. Okay, there's plenty more. As you can see here, the list goes on. Okay, so there are different types, and many more boards are being created every year, so don't be surprised. So we are using Arduino Uno, so that's good. The next one is we're going to set up, sorry, it's loading. Okay, so this is one problem with your what do you call this, non-installed application, because I picked the non-installed one. It's, yeah, I picked this one, the non-admin install. So it's better if you install it actually. Okay, moving on. Now again, you need to also set up your port, meaning you need to help your computer identify which port you are using for which or for what, for which Arduino that you want to upload it to, because you can actually connect multiple MCUs on one computer. Okay, so if you want to use the first MCU but you actually selected the second one, then the codes will be uploaded to the second MCU. So be sure to identify which MCU you want to use or you want to upload your files to. For this case, I don't have my own MCU, I don't have my own kit, so it doesn't show here. This one is actually a default one, just so you can try out your what do you call this one, serial monitor, but it doesn't have an actual MCU. Okay, there you go. Now, going back to your toolbar, okay, we have what you call here on the far right side, top right, we have your serial monitor. This is where you can interact with your MCU. If you made a code wherein people can or users can enter an input, like for example A, B, C, A or B or C or etc., okay, or any inputs, then this is where they can interact with your code. Okay, now going into your code. Now I will be including a link for you to be able to check on the codes provided by Arduino. Okay, so we have this website from Arduino, okay, which is titled Sketch. So Sketch is the programming language used by Arduino. Okay, so I think it's, if you are knowledgeable about programming, it's very close to, I think, C++. Okay, there. So a sketch is a name that Arduino uses for a program. So first off, first part of the codes is this one. So if you notice, it starts with a slash and asterisk and finishes with an asterisk slash. So again, it says here, these are called your comments. So comments, everything in between these two is ignored by Arduino, so it is not read as part of a program. Though it's included in the text, it doesn't do anything but just as label or a guide for other users to be able to understand. So for example, if we go back to our code, okay, so in here we can place slash asterisk and we can write something like name or programmer. Okay, so JC, okay, and then date when I created it, so it's April, or sorry, May something, and etc. Whatever things you want to add there. Okay, this is comment for multiple lines. Again, multiple lines. So if you want there to create a novel here, okay, like for example, this program is created as a demo code for grade 7. There you go. So multiple lines, but still not part of the code. Okay, now there is also what they call a single line comment, okay, which is indicated by this double slash. Sorry, it's a double slash. Okay, so from our code, we actually have it here. So double slash followed by the text, the statement, the phrase, the term or the label that you want to place there. So this one is actually used as a label saying put your setup codes here, run once. Okay, so this is a guide for you but not part of the code. And we have another one here. Okay, next one, we have what you call variables. Now just like in your math subject, we have your variables x, y, z, or a, b, c. It's almost the same here, but for programming, it's suggested that you should exercise using words or phrases that make sense. Like for example, we have lead pin. Okay, lead pin or blue pin or lead, for example, just to identify or just so you can easily understand that that LED is connected to specific LED on your MCU. Okay. Okay, so the setup for your variable is, first one is you need to identify the data type that you want your variables to hold, meaning what are the values that will be what are the values that your variables will be holding. Is it numbers? Is it letters, words, sentences? Is it decimal numbers as well, and etc. So if you actually just type there data types, you will see the old ones, such as the most common ones will be, in programming, there you go. So we have here the common ones, which are there you go. Okay, so we have here, these are the most common ones. So first we have integer, which is actually when you use it, you're going to use the keyword int, and it holds integer values. Okay, these are more complicated ones. Okay, this one. Okay, so we have int for integers, so whole numbers, negative, that ranges from negative 32,000 to positive 32,000. Next we have, those are int, same int. Okay, we have your float. Okay, so the keyword there is float, which is for decimal numbers. Next one we have char or char, whatever you want, however you want to read it. So it's for characters, so single what do you call this, single letter. Okay, next one we have string, is for phrases, words, sentences, as long as they are inside a double quote. And for character, each character should be inside a single quote. So when we use it, let's go to the first part. Okay, so when we declare a variable, going back to our code, so when we declare a variable, we type the data type first. So usually we use numbers, so int followed by the variable name. So let's name it LED. Okay, since we already have one here, so name it LED. Okay, and then we are going to give it an initial value. That's why this is also called initialization. So initial value would be, let's say 5, because we are going to use digital pin 5. Okay, so the 5 that we want to refer here is, if we were to go back to our code, we are going to connect wire in this digital pin. Okay, this digital pin 5. Okay, next one. Okay, next one is we want to okay, next one we move on to your so that's for the first part. This is for initializations. Okay, so if you want to add another LED light, so just type int LED equals 6. Okay, you cannot duplicate any of this except of course the data type, meaning this second one would be wrong. So if we verify this one, you will notice it will show an error because int LED is already declared here. So what do? We add a number. Now when creating a variable, do not use numbers on the first digit here. Do not put 2 LED, okay, because it might create an error that will give you a headache. So place it after the word. So when we verify, now it's good. So if we want to create another one, so it's int LED 3 is equal to 7 semicolon. So usually each line you finish with a semicolon. Okay, again, each line is finished with a semicolon except for what do you call this one, curly braces and functions such as this one, declaration of functions, which we will discuss later. So if you want to use float decimal points, so just type float. If you notice, it turns into the same color as your integer, meaning data type, it's acknowledged as a data type. And then we say del, then we give it a value 9.9 semicolon again. So if we verify, okay, so there's no error. But what will happen if we put the decimal point here? So if we were to verify that, there will be no error, but the 0.9 will not be considered. Okay, so delete that. Okay, moving on, we have your functions, otherwise known as a procedure or subroutine. It's a named piece of code that can be used from elsewhere in Sketch. So one example we have is called your function setup. So what does setup do? Okay, setup will run codes inside it, which is inside those brackets after the setup. So to show you my code that we have void setup. Okay, so we have here function called setup. It will run the code once. So you place codes here. So according here, first line provides information about the function, like its name. So this is named setup. The text before and after the name specifies the return type and parameters. This will be explained later. Okay, so we have the code between curly braces is called the body of the function. Okay, so this one is the body of the function. So in our example, we have here curly brace opening until closing. That's the body of the function. Next one, you can call a function that's already been defined either in your Sketch or as a part of Arduino language. For example, pin mode, then we say LED output. This one calls for a function called pin mode. Okay, passing two parameters. The first one is the value of your LED, and then we have the word output. So going back to your hardware, there are different types of modules. Okay, so these are different modules here. We have DC motor, microservo, we have RGB LED, and many more. LED light, resistor, potentiometer, push button, those are modules. Now there are two types. We have your input modules and we have your output modules. So input modules are something that would provide a data for your Arduino to interact with. Okay, so it can be something that a person can interact with. So For example, we have push button where any person can press the button and it will give the Arduino values zeros and ones, or open and or close, or high or low, zeros or one. Okay, same as potentiometer where people can what do you call this one, can turn the value of the potentiometer and it will give it the value from 0 to 1023. Okay, so those are your potentiometer, your input modules. Output modules are something that would be used by your Arduino to react to whatever codes or whatever inputs that it detects. Okay, which are your LED lights, that's one output. We have microservo, we have DC motor, we have RGB LED light, so it just turns into different color depending on how you program it, and many more, because these are just basic components. Okay, so you can search more of those. Okay, so you identify it if it's output or input. Now when you type pin mode, make sure that M there for mode is capitalized. When you type input or output, make sure that it's all capitalized. Okay, so sir, when do we use input? So for example, we want to connect a push button. Okay, you want to connect a push button to your MCU, and it will be connected to it will be connected to your MCU. So for example, we have this one. So let me erase this. Okay, so this one. Okay, if you notice, we have a setup here for a push button. So it's connected to your digital pin 2. At the same time, 5 volts and ground to power it up. Okay, so what we do there is we go to your setup. First, we identify the pin just so we can give it a name. So we say int pb for push button. Okay, or we can write p button is equal to 2. Why 2? Because we are going to connect it to 2. Now 2 here will be the one to detect the data that your push button is producing. For example, if we press it, it will give the value 1. If we release it, it will give the value 0. Okay, next one is we have your we have the one called your going back to pin mode. Pin mode function configures a pin as either an input or output, just like what I mentioned. To use it, you pass it to the number of the pin to configure and the constant input or output. So in our example here, this is the pin that is being asked, the number of the pin. So sir, why is it not a number? So what happens here is pin mode will actually get the value of LED, not the word LED, but the value of LED, which is 5, and we'll say that 5 is an output. Okay, so if we were to assemble it here, let me add some LED resistor, goes there, it's connected to 5, and we have this one is connected to ground. Okay, so now we have a LED light that is connected to digital pin 2. Now if you're wondering, sir, why did you not connect it to 5 volts? So if you want to program your LED light, it's you should be connecting it to digital pin here, so that you can control if it will turn on or if you want it to turn off. Because if you place it on 5 volts, it will just continuously turn on. Okay, oh sorry, this one's wrong, so we interchanged. This one should be ground, this one should be 5. There you go. Now if you thought of that correction, then good, that's a start. Okay, now next one is, okay, so we go to digital write. So digital write functions output as a value on a pin. So we are going to interact with one of the digital pins. So we are going to write, meaning we are going to do something about that digital pin. So how do we use this one? First is you write the keyword digital write, followed by a parenthesis, followed by identify which pin. So for this, the one on the website, it's written in lead pin, but for our code it's written, so let me delete these ones for now, we just use lead, so it's written on as lead, and then it's an output. So the way we use this one is we type digital write, digital, make sure that W there is capitalized, digital write. There you will notice the color would change, followed by the variable name, which is lead, because we label digital pin 5 as lead. Okay, comma, followed by what we want it to execute. If you type high, it will turn on the LED light. Okay, if we type low, it will turn off the LED light. Okay, so let's try putting there high, followed by a closing parenthesis, followed by your semicolon. Okay, next one we have the function called delay. So delay means it will wait for whatever value you placed inside the curly brace. So for example, we have delay 1000. So what does this mean? So when you write delay 1000, okay, the value inside will be read as value for millisecond. So if you place 1000 there, that is considered 1000 millisecond, meaning it will wait for 1 second. So again, 1000 millisecond is 1 second, or 1000 delay is 1 second delay waiting. Okay, so there you go. Now next we have setup and loop. So again, setup, these are two special functions that are by default found on your Arduino sketch. Okay, setup is called once, so this will execute only once, while loop will keep on executing over and over again, and is heart of most sketches. And so it's the heart, so meaning it will initialize and execute codes over and over and over without ending until you actually stop the robot yourself, manually stop. Okay, you need to include both functions in your sketch even if you don't need them. So it's required for you to use them. So that's loop. So let's try to finish this code and make a code that would turn on for 1 second and turn off for another second, and will keep repeating. So it will keep on blinking. So how do we do that? So the first line here, digital write LED high, will turn it on. The next line will wait for 1 second. After 1 second, what should happen? Okay, so it should turn off. So how do we turn off your LED light? So we write digital write LED, the same function, the same LED light, the same pin. Okay, and we say it should turn low or off, and then we'll wait for another second before executing another line of code. Now notice it stops here. So you will be asking me, sir, why stop there if you want it to keep on blinking? So remember that this function, void loop, will repeat this code, the function's body, over and over and over again. Okay, so if we actually try to analyze the code, we turn on the LED light, wait for 1 second, we turn it off again, wait for 1 second, and then goes on a loop, and we turn it on again, wait for 1 second, off again, wait for 1 second, and goes back to the loop. So if we check this one for error, nothing. So again, this application is used if you actually have an Arduino kit, but since I don't have one, I'm gonna copy this code and go to our virtual Arduino TinkerCAD and click code here, and you will notice the codes that is placed here by default. We just delete that one and paste our code. Okay, so once we're done, we can start. Now before I start the simulation, I would just like us to compare the Arduino application and this simulation. So if you notice, we have the codes here. For our TinkerCAD simulator, we paste our codes here. Okay, if we want to start the simulation, for the Arduino application, we upload the code. So once you start uploading, it will immediately execute, or if it's done uploading, it will execute your code. So let's try it out on our virtual Arduino. So start simulation. So there you go, it already started. If we close, so notice the LED light is turning on and off for 1 second intervals. There you go. So now it's working. There you go. Okay, so that's it for the basics of Arduino codes. So hopefully you were able to understand. So in case you didn't, you can watch other videos in YouTube. There are plenty of resources there. If you fail to understand something in this video, you can just pause and rewind, replay. You can play it in slow motion, I think, and watch it again. Okay, and I have an activity for you in the post provided. Thank you and take care.